It's original song. ChatGPT created just for you.
That's amazing.
Right? So walkout stats song, the tune, the simple melody like Twinkle Twinkle Little Star. When you walk out stats in hands, numbers help you understand. Mean, median, and mode helping lighten the data load. Standard deviation shows the spread with variance in what's ahead. The chorus, walkout strong stats in your side. Truth in numbers we won't hide. Graphs and charts will analyze, finding patterns in disguise. ChatGPT for the win.
That is going.
Yeah, luckily we were recording that. That's going in. That'll be the intro to the podcast. That'll be great. I love it. Well done, Kevin. Welcome to Technology Tangents. We get leaders together to discuss the important tech of today and the implications for tomorrow. Our discussions are fun, lighthearted, and frankly opinionated. It hopefully gives you a sense of what matters, what to pay attention to, and what to ignore. Today we're going to talk about DeepSeek and R1. To do that, joining us as always, Jason Goth, our CTO. How are you, Jason?
I'm good. Did you get an iPad?
I have a little iPad here so I can have some notes and seem more prepared because you can see it in the video now. It's not just a talking head, but you can see that I'm not.
It's like I've never seen you with an iPad.
Did he get one or did he take one of Jake's 10 of them?
Jake has a stack. I just grabbed one at random so I can look smart.
Okay.
Exactly. Yeah. That's right. How are you, Kevin?
I'm doing great. Happy to be
ready?
here.
You excited?
Always.
I hope you weren't planning on selling any stock yesterday or today because DeepSeek came out. R1 was released and $1 trillion of market cap gone. Kick us off, Jason. What do you know about
a mini iPad versus a bigger one?
That's right. That's why I have the exactly. What are your thoughts on DeepSeek? Like, what is going on here from your perspective?
Well, it's super interesting. I looked at it. Actually, you had sent me some information about it last week, and I had researched it and looked at it and read some of the papers that were published and did some evaluation, and it is really impressive as a reasoning model. And so if you look at it, it's essentially a foundational model like OpenAI or Llama or any of the other Claude, any of the other models, and however it is very focused on reasoning. And, it scores incredibly well on these math tests and all the different reasoning tests that they use to evaluate models. I think what has gotten everyone all excited is they're somewhat taking a novel approach to building it instead of doing, train up something on the entire internet for several months, spending tens of millions of dollars. They took they claim to have taken this is what I think the source of a lot of the debate is. They claim to have taken a very different approach, which is to do a cold start with some labeled, data from the internet and other places, other sources, and then really focused on doing a lot of reinforcement learning, right? So reinforcement learning is it gets an answer and someone says, yes, that's a good answer, not a bad answer. And the claim is that, by doing this reinforcement learning approach, that they've been able to train it to get just as good or even better results in reasoning as some of the larger models at a very fraction of the cost, like $6,000 or $6 million or something like that. Yeah. And so, of course, what that, the immediate knee-jerk reaction in NVIDIA and all the markets is like, well, maybe we don't need all of these GPUs and we've got plenty of hardware to train because this is now. I think it's a little bit of a knee-jerk because who knows if this is true? Has it been, like, how many papers have promised that they've gotten cold fusion working, right? So there needs to be a lot of validation, and in the end, you'll still need GPUs for inference, and I don't think it's going to have any material impact on NVIDIA or any of the chip fab market, but it does raise an interesting question of how what are all the different approaches to training these models and how good can they get, looking at different ways. The breakthrough for GPT was the attention mechanism, and so is this another breakthrough with reinforcement learning and their approach to, they don't just do reinforcement learning, they do it in like buckets, like reinforcement learning on this topic and that topic. They call them group policies or something like that. Will that also have a big breakthrough think the answer is maybe, and maybe there's going to be many more breakthroughs, but just like I think the entire history of this business, there are going to be breakthroughs that continually have an exponential increase in improvement in efficiencies and costs and everything else. But we don't have fewer CPUs than we did in the 1970s either, despite Moore's law. So I think it's not going to really, I think the market stuff is much ado about nothing. The bigger question is what, is this a true advancement in getting better results through a new training method?
So you said that this model for our listeners is really focused on chain of thought and reasoning specifically. Mm-hmm. What does that mean in context versus more traditional ChatGPT?
Well, if you use the example of a ChatGPT is memorizing facts, right? This is not exactly correct, but I think just to fire for effect, it's memorizing facts. You say the capital of the capital of France is, and you get a bunch of data from the internet and it learns the most probable response is Paris. Or you say, I don't know,
2 plus 2.
2 plus 2 is 4. Like 2 plus 2 is the most probable response is 4. Right. And so it's taking these facts and building a probabilistic response to the tokens that it sees. What's the most likely next thing? And so in a way, they're a parrot, right? They're repeating things that they've heard. They're really not understanding, but the parrot doesn't understand what it's saying. I think it was someone called the LLM stochastic parrots, right? I can't remember who said that. It's a great term, I thought. Reasoning is different in that it is, it is attempting to mirror our chain of thought, our reasoning, and be able to reproduce a set of steps to solve problems. If you were to say, like, what's 2 plus 2, it's not going to respond with the most probable answer. It's going to come back with, the way I would solve that problem is take the first number, add the second number, put it in a calculator, or, in this case, maybe code, create a Python script, take the first number, add the second number, print out the result, read the result. That's what I would do. And then the model can, if it has the appropriate research, access to tools, it can go and execute those steps to get an actual answer. A better example might be, give me all the what are all the countries and what are all their capitals? It might say, I'm going to go search the web and find a list of all the countries. I'm going to then, for each country, I'm going to go search the web and find, what the capital of that is. And then I'm going to take those results and I'm going to formulate up a response using the language features of the model. And so it builds these execution plans, if you want to use that term. That's what the reasoning does. Now, ChatGPT does reasoning. DeepSeek does, language generation, right? And so it's not that they don't both do the same thing. It's more of a focus where the DeepSeek is more focused on reasoning, and has at least in some of the tests has shown some better results at reasoning. It probably would. These are all trade-offs you make in model design. It probably wouldn't do as well as, ChatGPT on generating a poem or generating an image of Vincent if Dolly painted it, or all of these other top things you might ask. But, again, this gets back to the question, I think, of, is there going to be one big model, or are we going to have like smaller purpose-built models, one for reasoning, one for doing this step, one for doing this step, one for doing that step? I always think that has always seemed to be the more likely route to success, rather than just trying to cram it all into one brain. I mean, even the human brain, we specialize functions, right? And so that's a little bit of opinion mixed in with the explanation, but yeah, that's the difference.
So in short, sort of traditional ChatGPT models is like GPT-3, 4, 4.0 are effectively just giving the results. It's memorized an answer conceptually, not literally. And you ask it, what's 2 plus 2? It's seen that enough times, it just knows it can recite 4 is the correct answer. The challenge is that when you ask it a question like, what's 1.49265 plus 2.300004, it's unlikely that it has a large enough corpus of examples like that to be able to recite the correct answer.
It's never seen that in the training data.
Unlikely, right? Yeah. And so the idea of the reasoning is to ask the question, not directly answer, don't recite to me how to answer this, or rather don't recite to me the answer, but rather recite to me, how would somebody go about solving this problem? And so then it breaks it down into a series of tasks effectively. Like, well, maybe we need to transpose this to all powers of 10 so that I can sort of add up columnar, conceptually the way you did long addition, right? You like write them out, one column at a time, and then I can actually get the correct answer for something I've never seen before. So in the math example, it's kind of obvious how you might do that. In that simple addition, more complex problems, more difficult, but that's sort of the question is, how do we go about answering the question? And then each one of those tasks then gets its own model effectively to go invoke, well, how would I do this piece of it? And so the challenge then becomes the more steps that are required, the more complexity, the more cost there is because you're spinning up all these sort of sub-models. So to deal with that cost, OpenAI, to your point, allows you to do these things in the O1, but that's $200 a month. It's not the $20 version. It's the $200 version to get the really good reasoning. Gemini has deep research now. That is still $20 a month, but probably not for long. And so what was so unique is that this gives you that reasoning model. It's on par or better in some contexts than the traditional OpenAI or Gemini models, but it's open source. It's free. And it's fast. And then that's so fast and so free because it's a lot smaller of a model. So this model distillation, taking these really big models, distilling it down to its core, sort of what are the most important features of that is part of the breakthrough using reinforcement learning. I think that's really fascinating. And I guess, Kevin, the question to you is a bit of, I mean, this is, coming out of China. It's a no-name company with a bunch of researchers that haven't really done a lot prior to the first paper they published about reinforcement learning back in December, I think it was. How does this happen? Like, especially when you look at the tariffs, the sanctions placed on China to get good chips. These aren't the same chips we're using in the US, for example. They're far worse. How does something like this even happen? I mean, we have Microsoft, we have Google, we have Facebook, we have OpenAI spending billions of dollars, and this no name with no funding comes out of nowhere? How do you think this happened?
Yeah, I think the short answer, we don't know. I don't know. I can come up with plausible answers, come up with snarky answers, but to me, what I think is interesting is around just really the theory of disruption, and I think that's what's kind of so fascinating about the last week is it's one the utter meltdown response to markets and to considerations, but like as someone who doesn't understand as much on the technical behind the scenes, I love the fact that there's something that came out of left field that built on something in ways that was unexpected, that even if this is not the long-term solution or it's some degree of relevancy or accuracy, it proves the point that what was really been the path that we thought we were on for the last 24 months, which is going to be continue to build this way, will change. And I think that's pretty exciting. So again, I love the idea that there is opportunity for us to kind of, even the way of just listening to you guys talk about the explanation in the last few minutes, really it's around, hey, we took a solution, we're building upon, a path, and we're thinking about it slightly different. We're leveraging what was being gained from something else to make it in a way. I think cheaper, faster. I think the whole idea of what is core knowledge, and that really starts to become pretty interesting. It doesn't really answer the question, but like the implications of core knowledge and how that plays out to a company, a country, or something else is that you can start to say, well, wow, maybe we'll have this baseline knowledge that will be built the way it is, but then we can customize solutions much cheaper. I think time will tell whether or not the actual solution, what came out, what degree of that is I don't want to say real, but I think that specifically around chips and stuff like that, I think time will tell around that. But I think it proves the point there is really bright people thinking about problems in different ways, and I think that's really actually from a society perspective, take away country-specific needs and all the other things that go around with that. Actually, it's pretty exciting to think about that, and I think that there's probably lots of cool just anthropological reasons or apology reasons why it's interesting to think about how people think about problems differently. If you even go back to antiquities around what came from different parts of the world, part of that is the way they thought. It's possible some of that was in here. It's also possible espionage played in fact. Who knows, right? It's like that's the part that's kind of fun.
There are some conspiracy theories that it's just distillation of other open source models that were bigger, like Llama and other things. But
but even if that were true,
but
it's still amazing.
That's a good. I mean, I love that.
Use. And my answer to that is necessity is the mother of invention, right? So they don't have the resources, to go build 100,000, GPU, cluster of GPUs that, cost billions of dollars. So they took a novel approach based on the resources they have. It's always, my expression I use with our consultants a lot is constraints are good, right? They force you to focus on what's important and for that problem. And so they focus very much on reasoning as opposed to multimodal, these other things. And I think when you do that, you can come up with some novel invention.
Well, I think this is just more for my own personal humor. So, sorry, listeners. But you think about data that comes to you from different elements. And so, if I look at the last 24 hours, I had one thread with some really smart people talking about what Meta's planning to do and essentially announcing that they're going to build a data center the size of half of Manhattan. And then you've got the DeepSeek coming out where it's like all of a sudden, hey, I'm going to do it in a transistor radio box, and it's like, and just even that, the fact that how different, I know I'm the non-technologists here kind of throwing different ideas in, but I actually find that to be fascinating that, conventional wisdom up until a week ago was like you needed, essentially the power of the sun to be able to handle the compute needs that we're going to be able to do. And then no, maybe we can do it differently. And I think that is really exciting, just even thinking about the evolutionary journey that AI concepts have really taken us over the last couple of years, building upon, as we've talked about before, just really fundamental data modeling assumptions that have been out there for a while. Well, I think it's just kind of fun to be around today to think about what the art of the possible could be. And
maybe those solutions are great for a different class of problem, right? Maybe we still have to use the Manhattan size, data center to solve a different problem. Maybe we come up with, eventually those problems become more efficient, right? And solutions. And so I think it's a both and. I don't think that, at least this early, in a technology cycle that, anyone needs to lock into one thing, right? You need to have all the above strategy. Although I will say, and for anyone who watched the last episode, someone predicted that, a big trend this year would be smaller open source models. I think I win that one. I think I get can we put a scoreboard up here on predictions? Because I'm only 2 weeks in. I'm already up a big one.
Yeah, but does we still have the carryover? Do you have a loss effect from the previous year that
you're starting the year
starting over?
Oh, we're starting fresh.
Yeah.
Okay, fair enough. I think it's really fascinating and really powerful that this no-name company who has no resources, no user base, skyrocketed to the #1 app in the App Store. A bit like ChatGPT did when it first came out. I think it's amazing that we have the ability to sort of crowdsource and democratize, let people choose what's actually best, and the meritocracy works in that context. Does it say they're not? Different question. Are there longer implications? No doubt. But that's really powerful. I guess my question to you then, Kevin, from a strategic standpoint, you're any of these large tech companies that's invested billions, if not hundreds of billions of dollars, because you believed the economic moat, the strategic moat around your business in this domain, which you believe is critical to your future, was in the hardware, was in being able to build bigger models using world-class machines. We talked about the Elon thing a few episodes ago and just the scale of that. It was, that, again, thought to be impossible. How do you defend your business in a world that is moving this quick with capital investments that are this high?
Well, maybe the defense is really around, and there's the time horizon is different. So again, defending your business in the very simple ecosystem a few minutes ago was around, hey, yeah, it's going to be a hardware problem. We're going to work through that, or just even, frankly, there's a reason why the tech moguls, I think, are bellying up in Washington, right? The existential threat potentially was, how do we avoid regulation, right? And so it's like, so I think that, yeah, some of it is as you're leading a company, you got to deal with what you know before. So yes, now you have something that you didn't know or you weren't expecting, or at least the market wasn't expecting it, whether they were expecting or not, who knows? But I think you got to kind of fight that fight. So part of me where that goes back to, again, things that we've long talked about too, it's really around, you got to run a portfolio theory of options, right? And so you think about, well, hey, this is where we think it's going to go. So how do we protect that investment? How do we create those strengths? And there's obviously the large models, and again, this is my non-technical perspective. The large models are kind of all, well, this one's this model is going to go with that cloud provider. That one's going to go with that hardware. I mean, so you're starting to see those alliances being formed. There has to be room for the unknown. It has to be room for R&D and working through that, which I think is an also win, because I think in the world where everything is so temporal in terms of profits and those elements. I mean, you think about what happened yesterday, like, you may be more willing to spend on R&D if you're going to lose that much market cap in one day because something you had no idea was going to come out and knock you around. And so I think that's actually really good for us too, is that, if people can invest more and around that. Now, how much you do that, will you look at that? But my other reminder, or just for me, as I was kind of contemplating this last night, it was just a good reminder of, like, things will always likely get better. They will likely get faster. Some of those just general themes. Now, when and how, it may even have caused us to rethink some of the assumptions that we were making. Right? You start talking about, like, multiple percentage points of our of the electrical grid going to data point consumption. Like, some of that difficult. Does that even make sense that you would, like, you've got a software company buying a nuclear power plant? Like, there's a few things that you're like, maybe we were a little ahead of ourselves, but, like, because that doesn't, that seems kind of crazy when you think about it from that perspective. But then maybe it doesn't, because if you go back, and let's go back 150 years, how much power was being generated for steel companies? Like, how much? There was, like, so it's not like that. Then maybe it's not so random that you would be thinking about doing that. And so I just think what's really fun again for this is just kind of, it's almost like the whimsicalness of society advancement, and that we just don't know what we don't know. And sometimes you got to enjoy the, Vince and I were talking about this, whether this is a black swan event, who knows? I think it's too probabilistic for that to be, but there is, the unknown gets a vote, and I think that's kind of a good reminder for all of us.
Yeah, I think it's great. And this is, to your point, this was an unknown, effectively. We didn't know this was possible. We didn't know this new technique was going to come out and be so powerful, and so it's hard to strategically plan for it. But I'm curious, Jason, from your standpoint on the technology strategy side, I think we've talked about this before, but how do you prepare for these moments? Again, maybe nobody will use R1 specifically, but it will inevitably create a series of spinoffs that take the same general approach. And if the cost is really that low in a country where we have access to better compute than they did, it won't take long to at least match it in parity, which means that's probably a pretty significant technology shift from OpenAI or Gemini to a more open source model that we can get to in a second.
Right. But I'd also kind of, everybody just, take a deep breath. Like, there's thousands of applications that, these foundational models do, or functions they provide, and this is an improvement in one of them, right, in terms of reasoning. So let's just, I would, everybody take a beat. But I'd also say, I've used this analogy on the pod before of, no one wants a drill, they want a hole. The reality is there are very few companies actually building foundational models. 99% of the companies, are using those models to achieve something. They're oil and gas companies, or they're banks, or they're airlines, or hotels, or car manufacturers, or pharma, or whatever. It's unlikely those people are building foundational models. Just like it's unlikely, there are drills. You can buy a drill at Home Depot. There are different drills. There are a very few number of drill manufacturers that focus on, most people focus on, like, how do I use the drill to do what I need to go do? Build cabinets, right? Install stuff on the boat, whatever it is, right? And And so you have to decide, like, if you're listening, I would say it's a very different answer for if you are a company building the models versus a company using the models, which is 99%. For those companies, I think it's, what we've talked about in terms of, being able to adopt things quickly and maintain optionality, which is to, like, build things very modular. Start with an actual problem, make sure that, you have some measurable goals, build things modular so you can swap out components and then see if that improves what you're trying to do. Like, go get the other drill, see if it works better quickly. And if it doesn't, don't worry about it. If it does, great, adopt that and, get the other thing. But it's why, companies, I see these companies like, oh, we're signing this big $100 billion agreement, whatever, it's firing for effect there, $100 million agreement for, we're going to get all of the tools from insert your AI company here, and we're going all in on that. Like, I wouldn't do that quite yet. Right? This is not IBM where you're going to go buy the mainframe because it's the only option. If that's my answer to the non-tool builders, to the drill builders, the language modelers. Like, I think it's what you said. Like, I still think there are a giant class of problems that some of these models solve. Like, okay, maybe this is a more efficient way, but there's a lot of other problems that needs to be still improved and improved and improved. And there's, who knows what efficiencies, and these things tend to not be, go in a perfect continuous curve. They're stair-stepped a lot of times with improvements, and you've still got lots of, I still think there's going to be not one big model, but lots of small ones, and then some to coordinate, like the reasoning. And I think all of these different things are going to need continued training. So again, I would stay the course if I were one of those. But they're not asking me that. Those companies have there's two handfuls of them, and they probably have people that are a lot know a lot more about building those models than I do. Right, I'm much more of the apply these things to real problems of other businesses.
I think what's intriguing and is possible, like if I would have said, hey, where was the world a week ago for what we know today? If I was a company, I would build on one of the models and I would essentially train it on my data. And but it's still a fundamental thing, right? But I'm going to try to customize it that way. That was going to be where my competitive advantage was going to be. And in fact, my data is going to be in some type of an environment where it's secure. Well, now you still may do that. That still may be a practical approach. But now you're like, well, what if I take a model that has a lot of what I like, and then now I can actually tweak it to my specific use cases? And I don't know having a good example of what that means. But now it's not just about simply training. It's about actually thinking about, that's a different paradigm. And I think that's what's kind of exciting. And it's still, I think what we're saying, there's room for all these different elements, but that is a different view. And then if, let's say, the investment is simply what it looks like, well, that's even more intriguing now, because, well, now we're not talking about, just kind of, I have to go mortgage my future. And then we'll keep on taking, the equivalent of Moore's law. Well, logic would assume it'll continue to get more down narrow, which then we throw into all the other things that we've been talking around about where this gets done and how it happens. It's actually just, again, that's why I wake up, not to go back to the same theme, I wake up with a positive. I don't know what this means, but it just seems like this is a different also view, not this particular product company, but just we got to continue to challenge. I mean, we're still in the relatively beginning stages of generative AI and what that means and how it plays out. And, I think there's going to be a lot of different things like this that are going to change our presumptions. And, I think I'm intrigued by that. I'm intrigued. I've been thinking, Vincent, for the statement you made a couple times in the last couple of days around that hardware question around the quality of hardware or access. And even that question, I have no idea what the hardware is, but like, I guess I'm not assuming that they don't have access to things that we don't know, and different working through that. I mean, I think this is just, it's an interesting element of like, what are those underlying assumptions we make?
I mean, you're the mathematician, right? What do you think about these models?
Yeah, I mean, I think if you look at Jensen actually, so the CEO of NVIDIA, actually at his last keynote, had a really interesting slide that showed sort of how this evolution is progressing. and whether it's following some exponential, like Moore's law type growth. And we've seen sort of two waves in the past where you said this actually in the last episode, I was just rewatching a clip from it, where you're talking about, it seems like we're sort of asymptotically approaching some equilibrium of the performance of these models. And it's happened twice now. We just sort of went through one, as you were pointing out. This, again, seems to be the breakthrough to get us back on that curve, a bit like microprocessors were. Mm-hmm. We'd consistently hit these boundaries and we'd have some breakthrough. Oh, shoot, if we just do this, we actually get a lot more compute and a lot more room to go.
Caching, memory caching on the CPU, adding another core to the CPU. These are all things that,
Exactly. And so to your point, I think it's so early now, it seems arrogant to believe that we've already found some global optimum. The idea that transformers were around well before ChatGPT, well before attention, and we got some, they were useful. We used them a lot as autoencoders, but that's basically it. They weren't doing anything like we see today. That new mechanism to evaluate and refine the model gave us a breakthrough, and that's where we got ChatGPT and those models from. The idea that happened to be the globally optimal seems very unlikely to me. So the fact that we found a new one seems quite likely. It seems actually quite probable in some sense, some global sense. How quickly we found it, how much better is it, we'll learn over time, but I suspect it's not even the final one. I suspect there's still a lot more to be learned in this space of how do you optimize these things, and I think reinforcement learning broadly is an area that I continue to be fascinated by. Every time we've used it, from the days of Uber when we used it for surge pricing to now, it just has this sort of step function change. It's just the early days, a bit like perceptrons and neural nets were when I was in grad school. Like, yeah, they're kind of cool, but nobody really knows what to do with them but a handful of people. Good luck. It's not worth the energy. And then we have a couple of breakthroughs, and then suddenly it gets a lot better. So I'm not surprised is the short of that. But I do want to talk about the cost. So the fact that traditionally, we talked about, Elon spent billions of dollars. These models generally cost hundreds of millions of dollars in actual hardware compute costs. Not hardware costs, but the compute of that and the depreciation of the hardware. Hundreds of millions of dollars, months to train. We've reduced that by more than an order of magnitude. They said less than 10 million. They said 6 million. It doesn't include, by the way, 6 million doesn't include all the failed runs. So that might have started halfway through, something failed. They discovered it wasn't working. They'd start over. It doesn't include that. But the final run that actually worked, less than 6 million. That calculus, to me, changes strategically how companies might approach the problem. If any company in the world, aside from the ones that are already working on it, came and said, hey, should we build our own model? The answer was laughably, obviously, no, you should not. Don't even think about it. It's not even worth entertaining. Don't even go down that path. If instead it's $5 million, $6 million to build your own model based off of your own data exclusively with all of the characteristics you want, like, for example, DeepSeek, by the way, built in China, has all the censorship stuff in it. If you ask it what happened in Tiananmen Square, it's not going to give you anything worthwhile, right? It's going to give you a very non-answer effectively. So that is, I think, interesting and compelling. And it also solves some of the security problems we talked about with models. If you had a different training set of data that you actually owned and you could control and curate, that there's some benefits from that from a security standpoint potentially. But it does raise this question, does that change the strategy? Should some companies who are already investing tens of millions in refining these models, they have a desire to go to real scale, is it worth exploring this? And this gets to the open source question, starts to get the open source question, Jason. What are your thoughts?
I mean, it's a good thought because, does it make it, more or cost effective enough for people to build their own, drills? Essentially, I still think that the challenge with that is there's just not enough people that understand the math and the data science to actually go do that in most companies. Well, I'd say most companies have, even if it's you could do it for a certain amount of money. The two constraints people have are people to do it and the data, right? Like because it's not like you have the data. Like, it's going to have to be very, cleaned and processed and repeatable and tested. And there's more to fine tuning. And, it's why we typically recommend to people not to fine tune. It's not just because of the cost. It's because of the infrastructure and discipline, process, data management, and, just someone with the math skills and, it's like hiring, we was like, you can get a statistician and give them a set of data, and you can get some very wrong answers if that person is not, well trained in stats. It's the same here, and that to me is more the limiting factor than the cost on, hardware. Like, what's it cost to get someone who has experience building and fine tuning models or distilling models from other larger language models with the appropriate background in understanding, error and loss and ethics and all of that stuff. That person's $1 million person. Is any company going to go hire $4 million person, people's $5 million salary people so that they can build a $5 million model? So that's now a $10 million investment. It's like, well, it's not 100. It's still not something people I think are going to go do. Now, maybe for a really, really large company, and again, I think I used this analogy before. If you're, let's say, a telco, Verizon, AT&T, and you've got all the cell phone data of every call ever, and you want, or MasterCard, and you've got all the transactions ever, and you want to look for some very specific narrow use cases like fraud or security, DDoS attacks, that kind of thing on the network or in a financial network. Okay, that might be worth it. They might go hire that and they might do it. But like like a car manufacturer like Tesla, like, okay, they might go do that around their self-driving models, right? But again, is a cement company going to go do that? Probably not.
Sure. Yeah, and I think this is where, we are going to drop development costs significantly. I think you're right. Labor is still going to be the constraint, at least in the short term. There's probably 100-ish people in this country who know what they're doing in this domain of actually building these models ground up. But if the costs go down, if it's open source, and that's the other part, now it becomes open source, you can kind of see how they did it. You can tweak pieces of it. It opens it up to a sort of wider spectrum. Do you think that it continues to grow the talent and make those models intrinsically better and cheaper to develop? So you don't have $5 million people. You can have $5 $500,000 people conceptually. Or does that intrinsically bring a lot of, hidden risk associated with giving these people the opportunity?
I use the analogy of a database, right? It used to be there were 100 people that knew how SQL databases worked and how the optimizer built query plans and everything else. Like that knowledge has disseminated out to now most colleges have a class now where computer science majors build a small database because a lot of that kind of stuff is in the public domain and much more understood and best practice of ML. But companies still don't go build their own databases. Right, they still buy them from Microsoft or Oracle, get the open source ones from MySQL or Postgres. Right, that's like there's no value in doing that. Like, the argument you might have is like, yeah, because all SQL databases in the end are the same because their output is determined by what you put into them. Right, like it's the output of a SQL database is there's no differentiation other than speed, that kind of thing. So the point is, like, with my data, could I train one up to do some function? That's where that SQL database analogy breaks down. But I still think even at an industry level, right? So, take pharma, right? Are you going to build a model for, I don't know what pharma would build a model for, like molecule, or are those things going to come largely out of research institutions and be adopted by others?
So with Meta releasing Llama, open sourcing it, DeepSeek-R1 now, how is the open source model actually changing the AI landscape if it's not going to enable people to go build their own?
Well, I think it's because they can go implement, just like MySQL, right? I don't have to go spend $1 million a year or a month on Oracle or SQL licenses. I can go, this thing works great, it scales, it's a much lower cost, and I can just deploy it.
So then why would a company choose to do that? What are the strategic advantages of open sourcing something like R1?
Yeah. Well, I don't know. But I'll go this way. I mean, I think that to me, maybe a different way to look at the question is really around, we have a bunch of comparables to where there's products that are open source and there's closed in industries that make sense. And there's different reasons why you do one versus the other. Whether you do it in database, whether you do it even in terms of application strategy. So I think it kind of goes back to my favorite theme, competitive advantage, what you're trying to do and what you're thinking through that and what you would use those for. I don't know why you would do one versus the other, but I think they're going to likely see that, just like we have seen that in almost every other kind of major technology advancements. I think you think about just going back to just pure mobile, that'd be an easy one to where you could see how that played out different ways. And
iOS versus Android, right? One's open source, one's not.
Yeah, and so how that played out, and there's a room for both, and they play out. I think. I think it's going to be an element that if you look back just a little bit in the last 10, 15 years, what else we also have seen? Well, you've seen the cloud providers and the hyperscalers continue to take functionality and make that into their core product. I would imagine you'll see that. We're already seeing that somewhat with even the closed source models here, but I think that trend's not going to stop. And so, I think for a company, you're going to have to continue to invest, where you would do that unique. You use the example, Jason, of a particular industry, a pharma type scenario. Like, it's going to be interesting there too. Like, where do you have applications and that become within a certain skill set that makes sense, that you can accelerate while you keep certain things to yourself that are. And so I don't think these decisions change. Now, how you make them and how rapidly where you work through those are going to be interesting, which is why I think, not to, you talk about you got geopolitical elements of all this with China and, just regulation. And I think for me, generally speaking, the more that companies and countries compete against each other, the more that I think that's actually to everyone's benefit. And so that's what also I would take from the last few weeks, that we're seeing that, where that's actually really healthy. And hopefully that continues to create great outcomes for consumers.
Yeah, I want to come back to the geopolitical in 1 second. But one last question for you on the open source versus the closed source. Are closed source models still viable in your mind?
Yeah, I think it's just like Kevin just said around, there's a Android, iOS, there's, MySQL, SQL Server, there's a place for both. I mean, that largely depends on a company's tolerance for risk and how much effort they want to go spend in terms of maintaining something spending money on maintaining something open source versus buying something and having someone else maintain it. And again, everybody has their own, tolerances there, or opinions there. And so I think, both will continue on. And I do think, again, the open source community will have breakthroughs. The closed source community will have breakthroughs. And, if you focus on, what are you trying to do and which tool does that best, you can come up with the right, combination for your company. It's just don't start from the tool perspective and figure out here's the tool we bought and what can we go do with it, or we don't know what we're going to do, but damn it, we're going to do it with open source, right? That's the open source models. That's probably not the right approach, I'd say.
Yeah. Do you think it raises the bar to your point of competition, which is to say, I'm less inclined to pay for a closed source model if it's not actually a premium product? I mean, I think the early days of the Windows Phone, certainly, was based on, or even the Android early days, maybe less so nowadays, Apple had a premium product and a premium experience for their end users relative to Android. I think that was a big draw early days. Now, again, I think you could argue whether it's true or not today, maybe not so much, but early days that was certainly true. Do you think that's going to be required in this context too? That open source doesn't actually have to be the same bar.
I think it could be one of the differentiate. I mean, I think some companies could use that as a differentiator. I don't think it's the only possible one. I mean, you could solve problems that the other models, again, there's an unlimited number of problems these models could solve. Yeah. It's, you solve, a specific one like reasoning, or maybe there's some other thing you focus on, like, image generation. I tried to generate an image. I was working with Emily Schulhoff, one of our partners here this morning, and she's talking about getting a new headshot done for LinkedIn. I was like, oh, let's just have AI do it. And I took a picture of her, uploaded to ChatGPT, said, clean this up for a good headshot for, and it came back with a picture of a man with a beard. I'm like, Emily was not happy with that. I'm like, okay, so this one, I won't name which one it is clearly not good at image cleaning up, but or image generation. But someone could. There's different focuses besides some of these like premium features, but that certainly is a valid point of differentiation.
Well, I think some of the themes we've talked about previously, just even around going back to the research needs, right? Hey, I'm willing to pay for access to where I can consolidate. My use case need is to be able to scan all this academic data, come back with an academic sounding paper. Well, you may pay for that. Well, the average user doesn't need that. The average user can just have the summary that comes not even from one of the actual AI models, like simply from using Gemini as part of a Google search. That's probably good enough for most people for a lot of the things that you're trying to do. So I think that will play out. And I think this is where it starts to get fun, too, to think about, well, where would you use that from competitive advantage or for how that goes back to. And I think what's going to be interesting is probably in many of our technical advancements over the last 200 years. I mean, ultimately, human capacity is the constraint, and it's going to be, how do we continue to think through different ways of how to maximize that time to what we do, and how does that tie back into what we do? And I think there's so much. The faster we find new ways to automate mundane tasks, we just realize there's more mundane tasks that we've just created that we have to go fix. I think that will continue. But it is intriguing to see how this starts to become I think the molecules are a really interesting element from a pharma use case. Like, what are the other things like that are creating really novel things that have implications that we didn't know, which I think goes back to just, I think, at least for me, fundamental view of worldview of just this idea of curiosity and how we create. And I think that these tools continue to give us new frontiers to be able to explore that.
I keep banging my face on the microphone. Sorry.
Better than your head, maybe.
Yes.
Let me talk.
I also think there may be, from the open source standpoint, there may be certain use cases or people that want to use things, but they're, for whatever reason, have, very, are very sensitive around security and privacy because of their industry, or, it could be a government, or, it could be health information or whatever, where they've got these specific needs. The thing the open source models give you is the source, right? So, people always are like, well, it's models coming out of China. Is it secure? And I'm like, well, we can actually go read the source code, right? Sure. And look at it and see. And so if you're willing to go do that, you can validate and then have your own copy that you are quite assured, through internal review, meets these, kind of security or whatever privacy needs. So, I mean, that is an argument for maybe doing it the other way. But again, if you don't have those needs and something's available commercially and you don't really care and it's a lot cheaper and you don't have to invest the time to go do that, then go use that. That's why I just think there'll be, these are all tools, and there's not one tool in Home Depot. There's thousands, and you use the one that, for the job at hand. And I think that there's always new tools coming out at Home Depot, and they're really cool.
Yeah. And one thing to clarify, when Jason says you have the time to go figure it out, what he means, you can assign it to one of our staff members to figure it out.
That's funny. Yeah. Well, I think that if we switch to the geopolitical a little bit more, we talked in the predictions that regulations this year, especially around AI, were going to be front and center. Do you think this accelerates that conversation, or just highlights the importance of wrestling with these issues? Intrinsic to the Chinese model, we talked about the ethical implications of the censorship that it was trained on, for example. We talked about, or we didn't talk about this, but it is true that in the policy, the user policy of this, they own all of the inputs you provided. They own all of the outputs you provided.
Shocking. They're
They're going to claim that's their IP effectively. Now, how they do that, if it's actually installed on your machine, running locally and not sending stuff back.
And they borrowed some other IP to be able to create theirs.
That's right. Exactly. So I think these are the questions that I suspect many of our regulators, especially now with, the inauguration, that whole row of people were technologists who are going to be super keen on this. So what do you think will happen?
I think the administration has been very clear that the approach to deal with that is to remove regulation, right? And let some of the tech companies loose. And I think they repealed the executive order from the previous administration that was had, I think there were 50 something regulatory bodies that had to look at technology and approve it. And they're like, so I think they've been very clear that we're going to take the shackles off and let these companies go innovate and versus try to deal through it with the regulation. And so I think they've been very clear that's their approach.
Well, I think you say loose, let the companies lose. That's true. I also think let companies lose. It's a different philosophical perspective, and I hope it's not just about one administration versus another. That's where it played out in the last couple of weeks. But I think to me, we're we probably all have all three of us all have our own biases that are probably fairly aligned on this. But I think the more you let the competitive pressures, kind of look at through it faster, it's really just around, again, theory of constraints. So I think the more it happens naturally, and there's risk associated with this, and I think even particularly, there's risk in China, there's risk for us. It's risk in the U.S. too in terms of how we play through that. So it depends on what the end game is you're trying to go. If we're trying to continue to advance, I think allowing the people that do that best to have that. If you're trying to try to determine how to protect, I think that's the other thing you remember, how do we protect something from happening, what happened in the last 2 weeks with this coming out? And what would we be trying to protect? Are we trying to protect OpenAI's interests? Are we trying to protect our sovereign interest? So those are really questions. We all have different answers to that variable, and I think that's where, that's going to be intriguing to you how that plays out. But I'm just going to go science and doing discovery for the win, and we'll see how it happens.
That's good. I definitely think that you're right. The administration certainly wants fewer regulations on technology within the U.S. Do you think this amplifies further sanctions or other constraints on the technology in China?
Well, I don't think that Chinese researchers, governments care at all what the U.S. government policies are towards them, right?
Well, except for the fact that we do we control via export tariffs, et cetera, and import tariffs, the ability for NVIDIA to send chips over there, for example, or the ability for, as we see with TikTok, apparently, the administration has the right, no, the executives and TikTok not, we'll see, but they at least have the right to ban such things for national security interests. So potentially
I think these are incredibly short-term things, because the idea that China cannot design a GPU and manufacture one, kind of a silly idea.
Well, actually, that's an interesting topic we should talk about at some point. The manufacturing, the fabs that are required, there's really only one company in the world that knows how to make them. And everybody licenses.
You're talking about the lithography?
Yeah,
yeah.
The actual lithography, the UV lithography, to get chips of this density at those wavelengths, there's really only one company that can do it. So in some sense, you can control it, at least in the short term.
Short run. Yeah.
Similarly,
but that's not a U.S. company either.
No, it's not, but it's
a
controlled.
Netherlands company,
That's
right?
Yeah, exactly. Yeah, ASML. So the other thing you can do, though, is, again, there's only one company that's really figured out how to make these things at scale. And so, there are many mechanisms that you can do to control some of this. Now,
that's a short-term problem.
Agreed.
And again, that can be solved. And once it's solved, I would just say, and again, I'm not a politician, but I don't think you want to base policy on something that gets solved tomorrow.
Yeah. And we're way
in another way, maybe, yeah. In other words, focus on, this is the discussion we're having. Let's focus on what we're doing, not what other people are doing, and what you can control and what you can't. Again, go take the cuffs off and let the industry innovate and generate novel new things like this, and possibly hundreds of other discoveries, and focus on that, and don't focus on what's going on in your neighbor's yard, and I think you'll be fine. Yeah. But again, that's my I'm very much not a politician opinion.
Yeah. This is just fits in. We've talked about
the same for industry, by the way.
Yeah.
Focus on yourself, not what your competitors are doing.
You have a lot of posturing going on right now. I'm interested to see it, but even go back to the fundamental question, could you play that out? I think it's kind of intriguing what's going on with some of the stuff with China. I think that's going to play out over the next generation. But they have way too much North America debt or U.S. debt to be able to kind of control. So they have there's going to, everyone's got, well, I'll do this, you do this. I think that's goes back to our one of my favorite, kind of just the mad type scenarios and play this out. I don't know what that means. I don't know what that works through, but we know there's going to be saber rattling, right? That's been, for the history of time of politicians and leaders, and I think that's going to be, curious how that plays out. But there are a lot of competing themes. I think going back towards that, what's threat, what is real, just even how you approach it, and I think that's also kind of part of the interesting elements of this. And I think it'd be not. Just even having different countries have different IP, different things like that, I think is healthy for the overall global advancement. But I do think that this will be a continued theme for the next number of really probably the next couple generations of how this plays out between China and the rest of the world.
That's great. Yeah. So I want to just cap us on one last question, and then we'll close here around really. Is it the end of NVIDIA, broadly speaking? Meaning these things are being developed in regions that don't have access to the best chips, for example. They've developed models that are significantly smaller, that are significantly cheaper and less time to build. Do you think that ultimately is the end of NVIDIA, which is what's caused a $500 billion market cap erosion over the past day, or not?
No.
I'd say no.
Well, like I said, this is one model solving one class of problem. There's an infinite number of models that solve an infinite number of problems, and there's still all of these things still have to execute, right? Do inference at runtime. So there's not going to be any, again, this is the Jevons paradox thing, right? So there's more bank tellers today than when they introduced the ATM, right? And so it's no different for me.
Yeah, I think that's right, which is the demand is there. The need to have these models everywhere is important. And the fact that you're changing from train or pre-train compute and you're offloading that to inference time compute just means that you'll have more models because they're cheaper to develop and they'll need a place to run. And so you end up with just more runtime versus inference time versus the train time.
Yeah. Something else I would add too is I think it's a different question around, do we need this? I mean, companies have to continue to evolve, but it is intriguing to how much speculative valuation is in the stock market. Right? I mean, you have this type of drops. I mean, there's going to be competitive pressures. Companies are going to get a punch in the nose. You're going to have to adjust. But is NVIDIA that much worth less today than they were? Well, no. I mean, maybe their long-term future would be different, but you're still going to build a data center the size of Manhattan. And so it's like, I think that's what's intriguing too, is that you think about what is real value versus what is financial value. Again, questions all over time, but I think that was kind of also an underlying current of this. And then one last kind of pop culture thing for the moment, I think it's intriguing too, just some of the other information that came out around the love of Americans on parlay bets, which is a somewhat similar theme, right? A bit of risk taking, also probably a bit of desperation that gets associated with that. And I think it's just kind of intriguing, all these different elements as we start this new year, all these different things that are all kind of coming at us that kind of make our listeners want to come back and see if we have anything valuable to say.
It is interesting, this moment of high volatility, people are choosing the high variance play, even if it has a lower expected value on the promise that they'll get lucky and they'll be on that long tail. We're going to spend $1 billion on GPUs on the hope that the models will be intrinsically better, or we're going to make a crazy parlay bet on the hope that, it'd be game changing.
Yeah. It's like going to Vegas with John Gim.
Or Phil, apparently. Phil is also a big fan of parlays. So last thing then, for our listeners, what do you think the biggest takeaway from today is for them around the sort of change and evolution of reasoning models, R1? What's the takeaway?
It's what I said earlier, stay the course. Find problems that drive your business, go build solutions that do that, and, evaluate new things as they come out, see if they make that more profitable or either better revenues, lower costs, and keep, rinse and repeat.
Yeah, I just add, you don't know what you don't know. Enjoy the kind of that, just the ride of discovery and expect the unexpected. And I think that, and just kind of some point you just have to step back and smile and think about new things and how that plays out. But it is around, you're going to have your strategy and you have to go after it and you have to be adjust to it. But also you got to take the things that come after you a little bit with a grain of salt too. So, I mean, I don't think that, if this is around this type of change, if this is, fundamentally around, and as we continue to say, that may be different, but like right now, it's just your actionary cycle. So great. I mean, the world acts like it changed overnight. Maybe it did, but time will tell if that actually did happen.
Yeah, no doubt. I think this is the year of value. We talked about this in the predictions. It's the year to get value. So I think focus on that. Don't worry so much about the model. I mean, AI simultaneously got more powerful and more accessible, but you have to get the value for that to mean anything at all for your company or your business. So thank you guys for the conversation today. More to come, more to see what's happening in this space. For our listeners, thanks for joining us today. And if you'd like to learn more, visit the insights page at Credera.com. Thank you.